Hi. Yes, I am. No, I'm not going live tomorrow because I don't have time tomorrow because I've got so many clients. So I won't be able to go live tomorrow. I will be going live tomorrow night. Let me just stop that 'cause it's repeating. Just setting up 1 second. That one. And right. There we go. Hi guys, welcome. Sorry, I'm just setting up. I'm just trying to get this going so I can see what we are doing. Right, okay, so I want to show this one. Just make sure. Okay, so one of the things that I wanted to talk about today on tonight's session anyway is I wanted to make sure that you guys have actually taken the time, because people keep asking me about the practicals and the PAGs, etc., and how you can ensure that you have covered that. So one of the things to note when you look at your specification, there is a part of the specification that shows you what the practical activity group was. So number one, microscopes. It also tells you the techniques that are going to be covered or the skills that should be covered as a minimum. So this is what's there for us as teachers, but it's also there for you as students to guide you so you know what it's actually showing. So the one thing I would say to you is do make sure that when you are going through and practicing that you are looking at that. The other thing to know is it also says about the specification reference examples. So you can see quite clearly here, there's lots of module 2 and module 3, module 4 and module 5. So that means it can come up in any of the papers when it comes to the topic on microscopes. So just be aware of that. The other thing to note is if we're talking about dissections, it could be module 3 or module 5 or module 6. So again, it could come up in any point if they're looking at how you have assessed your skills on dissection. So just be aware as you're going through this that you are checking what it is that you need to do. So this is 1, 2, 3, 4. And you can see quite clearly where you are being assessed. Hi guys, if you're joining me. If we move on to the next one, you've also got 5, 6, 7, 8, 9, 10, 11 and 12. So make sure you're going through and using that to guide you when you're preparing. So you can see 2 and 3, which means this is probably going to come up in paper 1 or paper 3. This one being 2, 5 or 6, chromatography or electrophoresis could come up in any of those two papers. And again, if you're looking at microbiological techniques, that can come up in paper 2. So you can work out which papers things might be coming up on based on this part, which is in your specification and you have had access to. So do make sure you are checking that out. Right, what I want to do tonight is I want to cover some things that I haven't managed to pick up on in the videos that I've been putting out there so far. So I wanted to just quickly jump on. If people have any questions, please do ask away. So if you're just joining me, you can watch this back, but basically look through the specification and note at the end, it's towards the end of the specification. It actually has this, I've just snipped it straight from there. It actually will tell you which modules, so which papers are based on which modules they can assess you for that one. Okay, so what I want to do just now, hi Sahib, how are you? I want to cover, hi guys, everybody who's joining me, whether you're I'm double showing this on TikTok and on my YouTube at the same time. So I'm hoping that it's not lagging anywhere, but I have a funny feeling it may be lagging on YouTube at the moment. Sahib, if you can let me know, that'd be really great. I want to cover transporting animals. No, I don't. It's not transport, it's exchange systems and insect exchange systems. I have a feeling that that could potentially come up. Can electrophoresis come up in paper 1? It's a module 6. So paper 1, so if we're looking at the electrophoresis, that would be coming up as 6.1.3. But if we're looking at chromatography, then we're talking about 2.1.2. However, I have seen a question which was about electrophoresis, but with link to amino acids and proteins. So if they're going to ask that question, then that's where it could be lying. Between those two. So it really just depends on the question. Good. I'm glad there's no lag on that. Right. The insect exchange system then. So for those of you who haven't done it in a while, you should remember and go back over the exchange systems and look at the fact that we have got these insects which have these tough outer exoskeletons, and they do little or no gas exchange. You can watch my video on this already, but what's really important are the difference between the spiracles. So they will expect you to be able to label the spiracles, and they will expect you to label, because I'm copying this straight across, the fact that these are openings. So do you know the difference? This is an interesting one. Do you know the difference between the spiracles, the openings, which are in an insect compared to openings, for example, in a leaf? Could you describe? So if you're thinking about the transport of water and you're thinking about transpiration and you're thinking about stomata, stomata are the openings in the leaf which allow for gas exchange. Well, the spiracles are the openings in the insects which allow for the exchange of gases to occur. So it's really important that you aren't just thinking about transport in animals on its own. For example, it could be transport in animals compared to transport in plants, for example. So just be aware that when you are doing your revision, it's never just that topic area, that topic area, that topic area. It will interlink lots of them. So obviously your spiracles, these spiracles can actually be closed by the sphincter to prevent water loss. So this is where you need to actually think about the fact that if we're talking about water loss, what are we talking about here? We're talking about evaporation. When you've got evaporation, evaporation is looking at water properties. So the latent heat of vaporization, water, which is a liquid, will obviously evaporate into a water vapor, and that can then be diffused from an area of high concentration to an area of low concentration. So the spiracles can actually be closed by the sphincter. So sphincters are very specialized ring-like structures which allow for the closing and opening. So you have sphincters in your stomach, at your esophagus at the top and at the bottom of your stomach, which hold the stuff inside the bag. So if you think about your stomach like a bag, a sphincter at the top, a sphincter at the bottom, it's going to keep everything inside the stomach until you're ready to empty the stomach. And so therefore, sphincter is a ring-like structure that can close and open. So in this case, the spiracles are open, but they can be closed. So if they're going to ask a question about that, they could give you a bit of information, and it could actually expect you to understand that the closing of the spiracles is going to prevent water loss, but that closing of the spiracles is going to result in less gas exchange. And if there's less gas exchange, are the insects going to be able to move around? So it's about all of it interlinking the bigger picture in a sense. So opening and closing the spiracles can also be used to increase the ventilation. If you think about, I've opened the door right now because there was too much carbon dioxide building up inside this room. So I've just finished my group tuition sessions. I was doing lots of talking, I was asking questions, and because I was talking, because I was moving around a lot, my metabolic rate was higher. Because my metabolic rate was higher, my respiration was occurring at a faster rate. There was more carbon dioxide actually being produced, and therefore the carbon dioxide levels inside this room got really high. Now that affects my brain and my ability to think. If there's more carbon dioxide in the atmosphere, in this room, in this box, then that's going to actually result in less of diffusion occurring. So by me opening the door, that has allowed for that buildup of carbon dioxide to now leave and fresh air to come into the room. Well, that's the same with what we're doing with our lungs. When we are ventilating, but we use our muscles to change the volume and the pressure inside our thorax, which allows for that movement, that ventilation in and out. Well, by opening and closing the sphincter in these insects, that's also going to increase ventilation. So it's like the guard, yes, absolutely, Zach. It's like the guard cells for the insects. So if you've got cells which are going to allow the opening and closing, in this case, like the guard cells, then that's where they could say, what's the similarities? What's the difference? So the similarities is that you have cells which are going to allow for the opening and closing of the spiracles. What do we need to know about commercial use of plant hormones? What you need to know about commercial use of plant hormones is basically they can give you any example. So you should know about what auxin does. So rooting powders, for example, to have the apical dominance, the ethene for the ripening of the fruits, gibberellins. So you've got a stem elongation, therefore you're making your plants grow taller. So it really just depends what they are going to ask you in that exam. So going back to this one, what you should know is about the tracheae. So the tracheae are these important part here, air-filled branch tubes, and they're going to provide a large surface area. Now they are going to remain open by chitinous rings. So it's important you know the chitinous rings are there to keep it open. Now, if they compared that with the breathing apparatus in the mammals, we obviously have cartilage that maintains that opening. Chitinous rings maintain the opening here. So it's about potentially similarities and differences where they could go. You've got your tracheals. So as we go down, each time we're getting smaller and smaller and smaller. So remember, we've gone through the mouth and the nose into our trachea. Our trachea then goes to our bronchi then go to our bronchioles, and so it gets bigger and bigger and bigger. So what you're seeing here is when we look at the insects, it's the same thing, but it's smaller. That's really what that's about, is the fact that you have got these openings, these tubes, which are going to branch, then they're going to branch again. What are we doing? Each time we're branching, we're increasing the surface area. And by increasing the surface area, what we're going to therefore get is this ability for substances to move. There is a more exposure, therefore more exchange can occur when there's a larger surface area. Hi. So it's important to note towards the end of the tracheals, there is tracheal fluid. So you asked about what do you need to know about tracheal fluid. So tracheal fluid is there because we need to prevent dehydration. So we need fluid to be moved to the area to prevent the dehydration of the cells. Remember cells that are made up of a membrane, that are made up of cytoplasm, that you have all this stuff together. And if the water, which is on the surface, is evaporating, then water is going to move from an area of high concentration to an area of lower concentration, and then potentially cause the cells to dehydrate. So to ensure that, we create these the insects create the tracheal fluid. So that's to prevent dehydration. But with any type of liquid, you are changing the medium. So with regards to air to water, there is less oxygen in water than there is in air. So if you have this tracheal fluid, although you're preventing dehydrations, this is one way in which you can prevent the dehydration from occurring, but it's a negative thing because it will limit the penetration of air. And if it's going to limit the penetration of air, and it's the same with, there was a question once which was about a fish tank, and why in a fish tank do you need to have your filter and your filter that's obviously getting rid of any of the fluids which are potentially carrying the waste products. You obviously need to still clean out your fish tank, but at the same time, what you've also got is you need the air to be put back in to maintain a concentration within your fish tank, because your fish are going to be respiring, so they are going to be having a decrease in oxygen concentration and an increase in carbon dioxide concentration. That carbon dioxide is going to make it more acidic. That becomes a problem. So it's like all of this together, whichever way they want to go. So it's important that you understand that oxygen would be limited, that penetration of air for diffusion is limited if there's too much fluid. So therefore, if you have a larger insect, we've changed the surface area to volume ratio, we therefore have a higher metabolic demand. That's exchange system, higher metabolic demand, larger surface area to volume ratio. No, that's a lie. If it gets larger, it's got a lower surface area to volume ratio, but a higher metabolic demand. And therefore, they produce lactic acid, and the lactic acid actually causes water to move out of the tracheoles, and that therefore will expose more surface area. So it could be that they are asking a question that is expecting you to note that if you've got lactic acid is going to change the water potential and therefore cause the movement of water, that's osmosis, water to move from a high water potential to a lower water potential. So it is important that you note the difference, but you also link it to what the topic area is asking you. Is it asking you about a solute that's being produced, which is changing the water potential, or is it asking you about this structure, these spiracles, the trachea, the tracheoles, or the tracheal fluid? So it just depends where they want to go with that one. Right, let me look. What would you say to do? It depends on the days before, like leading up. I'm basically just throwing out lots of videos and doing questions of whatever students are struggling with. But what I would say is focus on what you hate, focus on the topic areas that you wish and you pray do not come up. Don't revise the stuff you've already got and already know. The stuff that you feel good about, you know it, just move on. Because it's the stuff you don't know that's where you'll trip yourself up. Yes, so the sphincter also would prevent dehydration, but remember, if the sphincter is closing the spiracles, that's therefore going to stop airflow getting in. So you want it to be where the spiracles remain open and the sphincters are only closed for a very short amount of time. Does oxygen dissolve into the fluid, then into the cells? So the oxygen will dissolve into the fluid, but at a very slow rate. So the oxygen you want to diffuse and then it be used for respiration. Why does that expose more surface area? So imagine you've got I'm going to think of it as really weird, a swimming pool that's filled with water. If I take a bucket and I move some of the water out, you're going to actually get more exposure to the sides of the swimming pool. No, I haven't put a Zoom link on this one, Tony. I had a bit of an issue with the thing that happened on my morning's session with the Zoom link, so I've not put a Zoom link out this one. Um, Eden, don't worry. It's because you're panicking right now, and it's because I'm talking about things that are different than what you have revised. Don't panic. You have content, you have knowledge, you will be able to do it. What's important is that you look at the questions that have been given to you and you take the time to really think about, well, what are they actually asking me? And a lot of the times, a lot of students get hung up on that they think, oh, I've been asked about the insects exchange system, so I'm going to start talking about spiracles. I'm going to talk about the trachea. I'm going to talk about the tracheoles. I'm going to talk about these branching surface area, blah, 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 blah. But the question was actually asking about osmosis. So what I want you to do with the questions that you're being given in the exam is take your time to see where they might be looking at other topic areas, because that is where it's going more and more with these questions. Where the topic's more likely to come up, I don't know. It could be anything. I feel like muscles, translocation, lipids. I feel like respiration, but in a funny way, is going to come up. I don't think it's coming up in the way you think it's coming up, but I could be wrong on that one. What else are we doing? Hormonal system. I feel like the hormonal communications potentially coming up. I feel like a respirometer practical is going to come up, but again, I don't know. It really depends where they want to go. So is diffusion straight from the tracheoles more efficient and faster than going into the fluid? Yes, you want it to go from the air-filled space straight into the cell rather than into the fluid and then across to the cell. So you want that exposure to happen at a faster rate. So if you think about the mammalian transport system, what happens is you go from the air, the oxygen goes from the air, and then the oxygen binds to the hemoglobin, and it's carried in the hemoglobin because that's a more efficient way, because not so much of it can be dissolved in the plasma itself. So that's why you need the hemoglobin for transporting the oxygen around. So with regards to other organisms, if they are organisms that have potentially a high metabolic demand and they don't have hemoglobin, they'll have some other form of hemoglobin, which is going to be a protein that is going to have oxygen binding to it. So it's important you note that they really could go in any direction they want. It really just depends. Yeah, I know it's an interesting one. Most people do wish that they would just give them a really nice 5 marker on for example, respiration, but I feel like coenzymes, they might go down more the route of the different roles of coenzymes, because if they're talking about coenzymes, they can talk about coenzymes in the respiration and photosynthesis if they want to do that. It's also module 2, because your coenzymes comes up in protein, so it can come up in any of the papers. So it really just depends on that. Oh, you hate every topic in biology. I'm sorry, you hate every topic in biology. Biology is awesome, but it's hard. People think it's the easier of the sciences, but it's not. Chemistry is understanding parts of it and then just applying that to the same sort of equations and topic areas again. So the content is much lower. For chemistry, it's more application based on all those different reactions, whereas biology's content is huge, and OCR, it's so huge. It's ridiculous how much you need to know more than the other exam boards. Right, hold on. Let me just say, where are we going? Could you talk about the insects, thoracic, and abdominal? Oh, it's like you knew what was coming next. When we talk about larger insects, so remember we've got these larger insects are going to have a high energy demand. So they're going to need to have a higher metabolic rate. And if they've got a higher metabolic rate, they need more oxygen. If they need more oxygen, that's for aerobic respiration. Again, make sure you're looking at what the question has told you. Have they stated aerobic respiration? Have they just stated respiration? Could it be both? So do make sure you're looking at what they've said on that front if it is a question about respiration. Obviously, if it's aerobic respiration, oxygen is the last electron acceptor. So we need oxygen for that accepting of the electrons from the ETC, combining with the hydrogen ions, and therefore creating our water, the water which is the waste product. So what we have to remember as well is every cell is filled with cytoplasm, which is liquid. Every organelle is a membrane-bound organelle with fluids inside it. Mitochondrial matrix is a fluid. If we're talking about the stroma, is a fluid. So when we talk about osmosis, that net movement of the water molecules from a high water potential to a lower water potential, if we were dehydrated, whether we're talking about plants, whether we're talking about animals, if the cells are dehydrated, they're losing water. That's therefore going to cause them to shrivel up. We've now got a smaller space. We're not going to be able to do those chemical reactions in the same way. So that's a bad thing. So therefore, we need to maintain that hydration within our cells. We also need to ensure that we are replenishing. So right now I can feel as I'm talking more, I am actually losing more water vapor through me talking because that water is going to be evaporating into water vapor that is then going to be diffusing out. And because I'm losing it, I'm losing water. I don't just lose water through going to the toilet, which I'll probably pause in about 5 minutes to nip to the toilet, but I'm not just doing it, but losing it because I need to go and excrete my urea and excess water. Remember, the urea needs to be removed. If I'm dehydrated, I still have to remove my urea. And this is where module 5 and your excretion topic comes in. Why would I need to go to the toilet if I'm dehydrated? Well, I need to remove the urea. And going back to a sphincter, I have got a receptor which is detecting that there's a problem. The toxic levels in my bladder are getting too high. Either the toxic levels are getting too high, there is a chemoreceptor there, or the stretching of my bladder, if it gets too full, because it's filled up and I haven't emptied it, is going to signal for the release of that urine. I'm going on completely random conversation here, but it's the tangent we're doing. But that's what's going to happen in the fact that I have got a signal that's saying you need to release this out the body because it becomes toxic and therefore will start to affect the cells around it. So it's this whole thing of biology is interlinked and the topic areas are huge. So make sure that you aren't just focusing one after one after one. Anyway, muscular pumping, changing the volume and pressure. So just like if we were comparing that to the mammals and the ventilation system in the mammals, we have that our external intercostal muscles lift our rib cage up and out, changing the volume and therefore changing the pressure so that we can get the air to flood in. Well, if they're doing muscular pumping, they're changing the volume and pressure inside the thorax, the abdomen. That therefore is going to change the pressure, making the air come in. And then obviously some of them actually have these air sacs, which are collapsible in large trachea, these massive air sacs. So they fill them up with the air. And as they're going through their flight, what will happen is they'll collapse that enlarged air sac down. And that will therefore mean that they have the oxygen for aerobic respiration. So what you'll see is some of the insects will fly and then they'll stop and then you'll see them pumping. And the muscular pumping that they're doing is ventilating and filling up those air sacs so they can then fly again. And that's why they don't just continually fly. Right. Just seeing what people have been saying. What's the link between coenzymes and proteins? Coenzymes are non-protein helpers, which are organic, and they come from your vitamins in your diet. So you've got vitamin A, vitamin D, all of the vitamins that you have to take in are the ones which are going to help you. The proteins are, for example, the enzymes that need them to be able to function. Does Rubisco have a coenzyme? Ooh, good question. Oh, I'm not sure on that one. I actually don't know. Let me find out. Oh. And this is the thing, I don't know everything. I know the topic areas that I teach. So they have cofactors. Magnesium being the main, of course it is, the main cofactor, but it doesn't actually have a coenzyme. So no would be the answer to that question. What's the difference between cofactor and coenzyme? So a cofactor is a non-protein helper, but a coenzyme is a non-organic, and a coenzyme is organic. So it's whether it's organic or non-organic. What's the just answer that one. What kind of questions could they ask on? It really depends. They could go down the route of asking about muscle contractions and then linking it to respiration, and then linking it to the movement of the abdomen to replenish the oxygen that's needed. It really just depends on that one. I don't know. I mean, it's hard to try and guess and assume what's going to come up. It depends. Whoever wrote it felt like they were going to ask the question. Cover this stuff. Honestly, the best advice I can tell you is don't do all of it. Do the stuff you hate right now and hope that the other stuff is there and it's just sitting in the background. You just haven't done it for a while. Can they ask just about insects, because I only ever did the fish? So the dissection, interestingly, let me bring this back down. The dissection side of things, I was just talking about that at the start. The dissection can be on anything. The example they've given here, dissection of a mammalian heart, isn't the only one. So the dissection of a mammalian heart is one example, but 3.1.1 is the exchange system. And so because that's the exchange system, that therefore means that they could ask it about the fish. And there is an expectation that you know that. So when you're going to the, let me just get the specification up. Yes, it is on YouTube as well as here. Let me just go. So I'm going to switch a second here. I'm going to switch to this one and show you. So this is your exchange system. And so when you're going through this, at G here, the dissection examination drawing of gaseous exchange of a bony fish and or insect trachea. So they could ask a question about it. Absolutely, they could, because it's in the specification. There is an expectation that you will know about dissection and how to examine and how to draw. I honestly do think that the dissection and biological drawings will come up, but on which one, I don't know. Salma, yes, my lives are saved on my YouTube channel. So the fish one's an interesting one because there's not really much about the fish for the dissection side of things, but it's definitely a case of when you're going through them to look at all of the topic areas. And let me just jump down. For those of you who are worried about your maths, down here at page 63, it does tell you all the maths as an expectation. This is recall from GCSE, and then biological formula to recall for your exam. Again, carrying on, and then it's the ones that they will be giving. So not recall will be provided in the assessment. So make sure you are looking at, but they're just the main ones exactly. They're not all of them. So there is an expectation, and this one's quite a nice diagram to show that. If you scroll down, this was where I was showing you the different things. So for those of you about graph drawing, construct, interpret frequency tables and bar charts, look at all the places that they could actually assess you on. So they could give you data on any of these topic areas. Understanding simple probabilities, any of these topic areas. So the key thing is your specification is there as a guide for you. And so that should be where you go to when you're doing your revision and when you're looking at what you need to basically get better at. What stats test would be in paper one? Could be any of them. So you should know all four of the stats tests. The t-test, excuse me, I feel like t-test is coming up. I feel like they're going to give you t-test and maybe make you decide whether it's the paired or unpaired t-test. For those of you who are only just coming across me, where have you been for the last year? Jokes aside, go and check out my video. If you've got a specific subject area that you want to revise, then all my videos are linked to the the exams specification for this exam that you're doing. Hubert, I wish I could sit the exam for you, but I wouldn't get 100%. I'd also make silly mistakes. I'm glad I don't have to sit it myself. And the reason being is because I sometimes switch things around in my head back to front. I wouldn't get 99%. I would say if I was to sit the exam, I'd probably get about, I'd hope 78 to 82%. I'd be happy with that. I'm not being humble, I'm being honest. The reason being is because I know I trip myself up. Maths for me, maths and biology is so difficult. So difficult. Yes, my videos on my YouTube channel are all free. Go and look at them. The whole course is there. The only thing I charge for is my group tuition sessions and my private one-to-ones. And obviously I've got my workbooks as well. But these sessions that I do are all saved on my YouTube channel and the whole course is there. I spent 6 months, I took 6 months out of actually working in a school to make sure that there was a course for you to go to because I go into schools to support them. And I was worried about how little there was for OCRA out there. And so I made it available. So I hope you find it useful and helpful. And obviously I enjoy it. I enjoy doing this. I enjoy helping you guys. Do I think paper one will be hard this year? I don't know. Paper three was easy last year. I would say easier. So I feel like maybe paper three is going to be the harder one this time. Oh, thank you. I basically want it to be that it's not just for you guys, it's also for teachers out there because there's a lot of new teachers who are coming into the profession and the teaching profession is hard. And we don't have the time to go and do as much research as we would like. And I've got 20 years experience of this. I have been doing this. I have been head of biology. I've been director of student progress. I've done lots of things before I started doing these things for you. And I did this because I wanted to be there for my girls. And so I only work when my girls are at school or in the 2 evenings that I offer at the moment. And so it's a case of I want there to be things that you can go and look at and watch and know that they're high enough quality, whether you're aiming for that E or whether you're aiming for that A star, you should be able to access that through my videos to help you to understand and then to be able to apply it. Don't plan on doing the retake yet. Know that it's going to be hard. Okay, go into that exam knowing that it's going to be hard. It's going to be a challenge, absolutely. Anyone who comes out of that exam going, oh, it was so easy, I hate that. And I hate that because they actually haven't taken the time to read the question and they'll have made some silly mistakes. So it's really important that you are knowing that it will be challenging, but just try your best. That's all anyone can ask of you is for you to try your best. And also take your time when reading the questions, because that's the bit that most students struggle with. And the other thing is make sure you've got detail in your answer. And when I say detail, I don't mean write an essay. I hate the stuff that comes to me which are essay based. The reason being is it's so much for me to read and to mark. I don't like that. Make it short, bullet points, make it specific, have those keywords to go to. Sorry, let me go back and just double check. So what does organic actually mean in biocontext though? Like if they were to make us decide whether something is either a coenzyme or a cofactor. The coenzymes you should know. You should know your coenzymes as being the NAD, FAD, coenzyme A, NADP, they're your coenzymes that you're expected, but it is a case of, hi Alice, that they contain carbon. That's what makes them organic. So if we're talking about, for example, your heme group for hemoglobin is made up of iron and bilirubin. Those two come together to give you your heme group. Therefore, the iron is a non-organic. If we're talking about chloride ions that are needed for amylase, that's a cofactor because it's not got carbon. So that's what you're looking for. How do you answer question on dissections you haven't done? How do you answer it? Well, because that is an expectation that you have gone through and learnt about that because it is a specification point. So if you haven't done the dissection and you see it in the specification, go and look at the textbook, go and look at the notes and make sure you are confident. They tend to ask more about the fish, where they expect you to know you've got to cut out the operculum, push the pencil in through the mouth, out through, to push up the gill flaps, and then you would cut the gill flap out. And if you put the gill flaps into the water, they will actually spread out, so you'll be able to see them clearer. But it's things like that that they're oh, there we go. Sahib actually answered the question for you. It's mainly remove exoskeleton. Yeah, you have to remove the exoskeleton, and absolutely you want to stain it so you can visualize what you're being able to see. That's test, and the answer is t-test, so you have to say. So unless it's very specific, then yes, they would want you to say whether it's paired or unpaired. So it depends. If it's a generic answer they want, then just write t-test. If you're unsure, just write t-test. You may lose the marking points if it was a specific one where they wanted you to note that it was a paired or unpaired. But if you are unsure, write t-test, because if you write the wrong one, you will lose the marking point. So if you're absolutely certain, write it's a paired t-test or it's an unpaired t-test. If you're unsure, just write t-test, because what they'll do is it'll say t-test and then in brackets, it will then say paired or unpaired. But if you were to say it's an unpaired t-test when it was paired, you would lose that marking point. So just be careful on the question. Structurally wise, what is the difference between motor and relay neuron? The relay neuron's much shorter. The motor neuron has myelinated neuron, so therefore you'd expect a myelin sheath. The diameter would also be different. There we go. Look, see, people are already doing it. And this is the best thing about group things. Why it's important, because you can actually help each other with teaching. But I will say, do not speak to people on the exam day. Try not to, because it will just stress you out. Try and get yourself in your own head. Is it worth doing old spec questions? Yes, it is worth it, but just make sure you've referred back to the specification so you know what is being asked. Right, I'm going to quickly jump to the questions that are going here. What do you think the 6th mark is likely to be? Oh, I don't have a clue. I don't have a clue. I feel like there'll be either a method or an evaluate question. feel like there might be a nice 6 marker though. I think you'll get one nice 6 marker and maybe one hard one. Oh, hi on TikTok now. I'm kind of jumping between the two. I'm trying to do both. What maths will be on the paper? 10% of it? I don't know. If you can explain the difference between TEM and SEM. So the TEM, transmission electron microscope, because it's TM, is very thin and therefore the light is going to go through, you'll only get a 2D image. The SEM, it's going to bounce the electrons off of the surface and therefore you're going to get a 3D image. So it's to do with the resolution as well. The TEM has the highest resolution, then it's the SEM, then it's the light microscope. Yes, Amelia, paper module 1, 2, 3, and 5 is paper 1. Do they provide us with the trickier surface area volume formula exam, e.g. a sphere? No, they don't. They asked that in one of the questions, Alice. Where they expected you to know the, oh, hold on, the circumference. Yeah, they gave them the, in the question that they actually gave, they told you to make the assumption that the surface area was the same going all the way around. So you had to work out the circumference of something to then work out the radius to then link that back to the question. So there is an expectation that you have some of that content from your maths GCSE to bring forward. Evaluate data, always look at how many, what was the sample size? How many intervals have they got? What's the gaps between the intervals? Have they controlled everything? Did they do a statistical test? What are the error bar sizes? So therefore you can talk about the validity in the data. No. The new spec is not a new spec. It's actually made it easier for you. So the new spec is that they've removed certain things and clarified certain things. It is exactly the same. So the grade boundaries I think will be the same. I feel between 68 to 71 for an A star would be my guess. But again, it's down to the papers. It's down to the students who sit it that year. Is there practicals for paper 1? There's practicals for all the papers. So basically go through and double check. Yeah, definitely not sampling though. What maths could come up on paper 1? Connie, you and both as well. When you say please help for evaluation question, I can only give you the help that I've given you. It all comes down to the context of the question that's been given to you. They are not going to give you the same questions that are in the past papers. They're going to give you something else, but there will be hints on how to figure that information out. So like if it's a graph, look at how many data points have been plotted. If it is a table of results, have they put the decimal points to the same number of decimal points? Is there units throughout the middle? Like there's so many different ways they can go. It just depends on the question. Absolutely. Absolutely, Amelia. Definitely write in bullet points. It makes my life easier. Although I'm not marking this year's because it's not worth it for me for the money. So yeah, it takes me too long to read your answers and to mark them because of my reading and processing ability. So actually, it does not work for me. So I'm not doing it this year. I've done this. I've done my good thing. I've done it for so many years that I'm not gaining anything more by doing it. But what I would say to you is when you bullet point it, you make the life of the examiner much easier to find you the marks. You are very welcome. When to use the different stats tests. So the different stats tests, Sabrina, is whether or not if you're looking at the comparing the mean of two sets of data. So if they give you, for example, temperatures from 10 degrees to 80 degrees, and it's an enzyme controlled reaction, but then they ask you to look at the difference between 40 degrees and 70 degrees. That's two means you're going to be looking at. That's a t-test. If you're looking at all the data from the 10 degrees to whatever I said, 70, 80 degrees, then that would be where you would want to do a Spearman's rank correlation coefficient, because you're looking at the association between one and the other. So it really depends what it is they've given you as to which of the statistical tests you want to use. Yeah, they can give you anything on the practical base. I feel like they're definitely going to ask you to plan one. In my gut, it's either respiration or photosynthesis, and lots on translocation. I feel like translocation can come in so nicely here. But I definitely feel muscles. But I could say every topic area basically where they could go, because it's how they interlink the questions. Chi-square test is where you are able to work out an expected. So for example, if I were to say that there would be no difference between the, let me think this one through, no, so I'm looking at, I would be able to work out the expected ratio of whatever it is. So the genetics is really easy to do. I could say that there's no association between one or the other. So if that's the case, and I have done a practical where I've sampled, I would expect there to be the same number of species in each of my sampled quadrats. So therefore my expectation would be 100% of this one and 100% of that one, or 50%, 50%, whatever it is, that they would be the same. So therefore, if I can work out an expected ratio and I look at that against my observed data, then that would be where the chi-squared comes into it. So again, it just depends. They could go down the route of another prediction I have is gibberellins and germination in seeds, because germination brings in respiration. It also brings in hormones. It also brings in your biological molecules. It brings in your genes. It brings in everything. So therefore, they could go down that route. Guys, I am going to have to go. I needed the toilet about 45 minutes ago, and I still need the toilet. So I am going to go because it's also my bedtime. I will be back on here tomorrow night after I finish with my clients. It's going to be a long day for me tomorrow, but I will come back on here tomorrow. And I will try and help you as much as I can. But the key thing I would say, go check out the videos of the topic areas that I've already put out there that you don't like, and see if you can use them to help you. Look at past papers, look at mark schemes, try and get your own little flashcards of those keywords. That will be the important part for you. And obviously, just be aware that you know stuff. How much you know will be different. It just depends, because you've all got your own different journeys that you've gone through, but you will know stuff, and you'll be surprised when the adrenaline comes how much you can then get across on paper. So it will make a big difference to you. So guys, thank you and have a good evening. Right, let's say goodbye to you. Let's say goodbye over here. Bye, everybody. And then I'm going to come back over here. There's so many things open. Where have you gone? Up here. And I want to